When China landed on the far side of the moon, they called it a scientific milestone. When their rover found a mysterious object on the lunar surface, they called it a rock. When their sample return mission brought back soil that broke every model we had for how the moon works, they called it fascinating. But here is what nobody is saying out loud. Every single one of these missions has produced results that go far beyond routine science. And the pattern of what China chooses to share, what it delays, and what it quietly buries tells a story that the press releases are not designed to tell you. What China actually found and admitted to. To understand why any of this matters, you need to understand the scale of what China has actually pulled off in a remarkably short period of time. In 1978, China had no space program worth speaking of. They had launched a few satellites, sure, but deep space exploration, lunar missions, that was the exclusive territory of the United States and the Soviet Union, two superpowers who had spent the equivalent of entire national economies racing each other to the moon. China was watching from the sidelines. Fast forward to 2007. China launches Chang'e 1, its first lunar orbiter, named after the mythological goddess who, according to legend, drank an immortality potion and floated up to live on the moon forever, which, honestly, is a much better origin story than naming your spacecraft after a Greek letter or a random number. Points for mythology. Chang'e 1 mapped the lunar surface and returned data. It was impressive. It was also, by modern standards, fairly conventional. The world nodded politely and moved on. Then came Chang'e 3 in 2013. China became only the third nation in history to achieve a soft landing on the moon. Their U2 rover, which means Jade Rabbit, rolled out onto the lunar surface and started sending back data. At this point, the international scientific community was paying attention, but not alarmed. China was catching up. That was the story everyone agreed on. But Chang'e 3 did something that quietly unsettled geologists. Its ground-penetrating radar looked beneath the surface of the moon, not just at it, and what it found did not match predictions. The radar revealed multiple distinct layers of lunar soil with a complexity that existing models had not anticipated. 9 distinct layers in the top, 170 meters of the surface, each with different compositions and densities, suggesting a geological history far more active and complicated than the dead, frozen world the moon was supposed to be. The official response from Chinese scientists was measured and academic. They published papers. They described the findings as important contributions to lunar science. They used words like unexpected and remarkable and warranting further investigation. What they did not do was stand in front of a camera and say what those findings actually implied. That the moon's surface had been reshaped repeatedly, that volcanic activity had persisted far longer than the accepted timeline suggested, that the moon, in short, was not the simple, well-understood object we had been teaching in textbooks for 50 years. Now you might say, fine, science gets updated all the time. New data changes old models. That is how it is supposed to work. True, completely true. But here is where it starts getting interesting. Every subsequent Chinese lunar mission has produced results that did not match predictions. Every single one. Not some of them. Not a few surprising details in an otherwise confirmatory data set. Every mission, every time, something unexpected. At a certain point, the consistent production of unexpected results stops being a coincidence. It starts being a signal. And if you are paying attention, the signal is pointing somewhere very specific. The far side problem. In January 2019, China did something no nation had ever attempted in 60 years of space exploration. They landed a spacecraft on the far side of the moon. Now, I know what you are thinking. The far side, the near side, what is the difference? It is all moon, except it is not even close. The far side of the moon never faces Earth. It is permanently turned away from us, locked in that position by the same gravitational relationship that keeps our tides rolling in and out. And that one fact creates a problem that sounds simple, but is genuinely brutal to solve. Radio signals cannot travel directly between Earth and anything sitting on that surface. You cannot communicate with it, you cannot control it in real time. You are essentially trying to drive a car while permanently blindfolded, which is inadvisable under most circumstances. China solved it by first launching a relay satellite called Queqiao, which translates as Magpie Bridge, positioning it at a precise gravitational sweet spot where it could see both the far side of the moon and Earth simultaneously. The relay satellite became the nervous system connecting the mission to its operators back home. That is not a footnote. That is years of preparation and enormous expense invested specifically to reach a place the entire rest of the world had quietly agreed was too difficult to bother with, so why bother? The official answer is the South Pole Aitken Basin, where Chang'e 4 touched down. One of the largest and oldest impact craters in the solar system, roughly 2,500 kilometers across and 8 kilometers deep. Ancient material, early solar system secrets, scientifically legitimate and genuinely compelling. But here is what the press releases did not emphasize. Every instrument on that mission came back with results that contradicted existing models. The mineral composition was wrong. The subsurface showed structured layers suggesting repeated geological events, not one ancient impact followed by billions of years of silence. The heat flow from the lunar interior did not match thermal predictions. Every single instrument, wrong predictions every time. And China had chosen this site deliberately, with years of planning, knowing exactly what questions they were going to ask. Which raises the one question nobody in mainstream space coverage seems willing to put directly. What did they already expect to find? The water ice situation. Let us talk about water, because water on the moon is one of those topics that sounds dry, and yes, that is a terrible pun, but is actually one of the most consequential things happening in planetary science right now. For most of the 20th century, the moon was considered bone dry, completely without water in any form. This was the consensus. It was the assumption built into every model, every mission plan, every discussion of lunar resources. Then, beginning in the 1990s and accelerating through the 2000s, evidence started accumulating that the lunar poles, permanently shadowed craters that never receive sunlight, might contain water ice. Various NASA and international missions found hydrogen signatures consistent with ice deposits. India's Chandrayaan-1 mission in 2008 found spectral evidence of water molecules on the surface. By the time China's Chang'e missions began producing data, the existence of some water ice at the poles was accepted. The question had shifted from whether to how much and what form. China's contribution to this question has been significant and quietly alarming for anyone thinking about the future of space exploration. Here is why water ice on the moon is not just scientifically interesting, it is strategically transformative. Water can be split into hydrogen and oxygen. Hydrogen is rocket fuel, oxygen is breathable air. A source of water ice on the moon means a refueling station. It means a base that does not require everything to be shipped from Earth at enormous cost. It means that whoever controls the water ice deposits at the lunar poles controls the economic and logistical foundation of everything humanity might ever do beyond Earth orbit. China's lunar missions have been systematically building toward the South Pole. Their upcoming Chang'e 7 mission, scheduled for around 2026, is specifically targeting the lunar South Pole with a suite of instruments designed to characterize water ice deposits in unprecedented detail. The mission profile includes a flying probe designed to enter permanently shadowed craters, the exact locations where the most significant ice deposits are expected to be. NASA's Artemis program is also targeting the lunar South Pole. That is not a coincidence. That is two major space powers racing toward the same resource for reasons that have nothing to do with scientific curiosity and everything to do with what comes next. China has not been subtle about this. Their stated goal is a permanent international lunar research station at the South Pole by 2035, and the instruments on Chang'e 7 are not just scientific tools. They are survey equipment. They are the kind of instruments you send when you are not just studying a place, but evaluating it. The cube, the hut, and the things they don't explain all right. Now we get to the part of this story that broke the internet for about 2 weeks in late 2021 and then quietly disappeared from the news cycle. In December 2021, the Yutu-2 rover on the far side of the moon detected something on the horizon. The image was low resolution, taken from a considerable distance, but it showed what appeared to be a roughly cube-shaped object sitting on the lunar surface. The Chinese science team, to their credit, did not immediately claim it was a spacecraft or a monolith or evidence of ancient alien architecture. They did what scientists are supposed to do. They described it as an object of interest, gave it a nickname, the mysterious hut, which is a translation of the Chinese description, and redirected the rover to investigate. Now, here is where the story gets interesting in a very specific way. The drive to reach the object took approximately 2 months. The moon's surface is rough terrain, and Yutu-2 moves carefully, pausing to let its solar panels recharge and its instruments rest during the lunar night. 2 months of the entire world waiting to find out what this thing was. When Yutu-2 finally got close enough for high-resolution images, the official explanation was that it was a rock. Specifically, a rock that had been thrown up by a nearby impact crater and happened to have an angular shape that looked unusual from a distance. Fine. Rocks exist on the moon. Impact craters throw rocks around. Angular rocks can look strange in low-resolution images taken at a distance with the sun at a particular angle. This is all completely plausible. But here is the thing that nobody who covered this story seemed to notice or mention. The explanation arrived, the images arrived, the papers describing the rock arrived, and then the entire episode was closed, officially resolved, move along. There was no extended discussion of what kind of impact creates that specific angular geometry. There was no broader analysis of the crater the rock supposedly came from. The resolution of the mystery was handled with a speed and finality that felt, if you are being honest about it, less like scientific communication and more like someone ending a conversation they were not enjoying. And this was not the first time. Earlier in the Yutu-2 mission, the rover had encountered what its operators described as a gel-like substance in a small crater. Shiny, dark, described in the mission logs as having a different color and luster than the surrounding soil. The explanation offered was that it was impact melt glass, formed when a meteorite hit the surface and the intense heat fused the lunar soil into glass. Again, completely plausible. Impact melt glass is a real thing. It exists on the moon. The explanation is scientifically reasonable. But the photographs were limited. The follow-up was minimal. And the substance, whatever it was, received exactly the amount of investigation that a confirmed impact glass deposit would receive, not the amount of investigation that an unexplained shiny substance on the far side of the moon would receive if anyone was genuinely uncertain about what it was. There is a pattern here, not of cover-ups, not of hidden aliens, nothing that dramatic, but a pattern of anomalies that receive official explanations with unusual speed and then get buried under the weight of the next announcement. Scientists, real scientists, love anomalies. Anomalies are where the interesting work happens. An anomaly that gets explained away in a brief statement and never revisited is not how science usually operates. It is how public relations operates. The geology that rewrites the timeline. In December 2020, China's Chang'e 5 mission landed on the moon, scooped up 1.73 kilograms of lunar soil, sealed it in a return capsule, and brought it back to Earth. It was the first lunar sample return mission since the Soviet Luna 24 mission in 1976. 44 years. The samples came from a volcanic region called Mons Rumker in the Oceanus Procellarum, which translates as the Ocean of Storms. The site was chosen specifically because orbital data suggested the volcanic rocks there might be younger than samples collected by Apollo missions. That turned out to be an understatement of almost comic proportions. When Chinese scientists analyzed the Chang'e 5 samples, they found that the volcanic basalt rocks were approximately 2 billion years old. 2 billion years. The Apollo samples collected between 1969 and 1972 ranged from about 3 to 4 billion years old. The consensus model of lunar geology, built on those samples and decades of subsequent analysis, held that volcanic activity on the moon essentially stopped around 3 billion years ago, give or take. The moon cooled, the interior solidified, the volcanic era ended. The Chang'e 5 samples pushed that endpoint back by 1 billion years. Volcanism on the moon was still happening 2 billion years ago, which means the moon was geologically active significantly more recently than everything we thought we knew. Now, 1 billion years sounds like an abstract number. Let me make it concrete. 1 billion years ago, on Earth, the first complex multicellular life was just beginning to appear. The continents were arranged completely differently. The atmosphere had a different composition. 1 billion years is not a rounding error. It is not a minor revision. It is a fundamental change to the timeline of how the moon evolved. And here is the part that kept lunar scientists awake at night when these results were published in 2021. If volcanism continued for an additional 1 billion years beyond what the models predicted, then something was keeping the lunar interior hot enough to produce lava for that extra 1 billion years. And the models do not account for that. The accepted explanation for how the moon cools over time does not produce enough internal heat to sustain volcanism for that long. Something is wrong with the model. The proposed explanations involve radioactive elements concentrated in the lunar mantle producing more heat than expected, or tidal forces from Earth contributing to internal heating, or some combination of factors that has not been fully characterized. These are legitimate scientific proposals. Researchers are actively working on them. But here is what the Chang'e 5 result actually means, stripped of the careful academic language. Everything we built our understanding of the moon's history on came from samples collected in a few locations by Apollo missions over about 3 years. Those samples were extraordinary. The science done with them was extraordinary. But they were from one geological era and a limited geographic range. China just showed us that those samples were not the whole story. And the part of the story they were missing changes the entire narrative arc. The moon was alive, geologically speaking, much more recently than we thought. That has implications for how we understand planetary formation, lunar resource availability, and the history of the entire inner solar system. One country figured this out by going to one new location and bringing back less than 2 kilograms of rock, which raises the obvious question of what the next sample return missions are going to find when they go to the South Pole, where the geology is completely different. The crater ages are completely different, and the resource picture is potentially completely different. China has already announced Chang'e 6, which successfully returned samples from the far side of the moon in 2024, the first time in human history that has ever been done. From the South Pole Aitken Basin, the oldest and deepest crater on the moon, the same place where U-22 has been quietly finding things that do not match predictions. The results of those sample analyses are still being processed, but if the pattern holds, which it has held across every single Chinese lunar mission so far, the results will not match the predictions. The part where it stops being just science. At some point in this story, the science becomes inseparable from the geopolitics, and that point is right now. In 2021, China and Russia signed an agreement to jointly build what they called the International Lunar Research Station. This would be a permanent or semi-permanent facility on the lunar surface, initially robotic and eventually crewed, designed to support long-term scientific research and, in the language of the agreement, sustainable lunar development. Sustainable lunar development. Think about that phrase for a moment. Sustainable implies ongoing. Development implies resources. The combination implies something that looks a lot less like a research station and a lot more like the early stages of an extraction and utilization operation. By 2023, more than 10 countries had signed agreements to participate in or support the Chinese-led lunar station project. These include several nations that are also partners in NASA's Artemis Accords, which is its own set of agreements governing lunar activities. Some countries are hedging their bets by signing both. The smart money, apparently, is on not picking a side too early. China's timeline is explicit. Robotic missions through the late 2020s, building infrastructure and characterizing resources. Initial crewed missions in the early 2030s. A functional research station operational by 2035. 2035 is 13 years away. That is not a distant future. That is the career horizon of graduate students currently in their first year of a PhD program. It is close, and here is the detail that geopolitical analysts and space policy researchers have been quietly discussing in papers and conferences that do not get mainstream coverage. The Outer Space Treaty of 1967, which governs activities in space, prohibits nations from claiming sovereignty over the moon or any other celestial body. You cannot plant a flag and say, "This is mine." That is explicitly prohibited. But the treaty says nothing, or at least nothing unambiguous, about resource extraction and utilization. If you land on the moon, find water ice, set up equipment to extract and process that water, and then use the resulting hydrogen as rocket fuel, are you claiming sovereignty? The legal answer is genuinely unclear. Different nations are interpreting the treaty differently. And when legal ambiguity exists in a situation involving valuable resources and major powers with competing interests, history suggests the ambiguity does not remain theoretical for long. China's position, as articulated by their space program officials, is that lunar resources are the common heritage of all humanity and should be developed cooperatively, which sounds very reasonable. It also happens to describe a situation in which the country with the most advanced infrastructure on the lunar surface has the most practical control over how that cooperation actually works. NASA understands this. The Artemis program exists, at least in significant part, because the United States looked at China's lunar trajectory in the early 2010s and decided that not having a permanent presence at the lunar South Pole by 2030 was not an acceptable outcome. This is not speculation. NASA Administrator Bill Nelson said explicitly in 2023 that the United States was in a race with China to return to the moon. He used the word race, the head of the American Space Agency. This is the language of competition, not the language of cooperative scientific exploration. The science is real, the discoveries are real, but the science is also the foundation of something much larger. A claim on the future of humanity's expansion beyond Earth. And the country that lands first, stays longest, and builds the most robust infrastructure on the moon will have an advantage in that future that may be impossible to overcome. What they're not saying here is the thing about Chinese space science publications that does not get discussed in the Western media coverage of these missions. The data exists, the papers get published. Chinese scientists present at international conferences and collaborate with researchers around the world. The information is not hidden in the way that conspiracy theories would suggest. It is available. But the timeline of publication, the selection of what to publish and when, and the access to raw, unprocessed data are all subject to controls that do not apply to NASA missions in the same way. NASA's raw data from planetary missions is typically made publicly available within a defined period, often to the scientific community fairly quickly, and to the public shortly after. The philosophy is that missions funded by public money produce data that belongs to the public. China's approach is different. The data is released, but on a schedule and in a form determined by the Chinese National Space Administration and the scientific teams involved. Raw data access for international researchers is more restricted. The peer review process for initial findings sometimes involves extended periods where the data exists but is not accessible to outside verification. This is not unique to China. Other national space agencies have similar practices. But when combined with the consistent pattern of unexpected findings and the geopolitical stakes of what China is doing on the moon, it creates a situation where the international scientific community is to some degree dependent on Chinese scientists to characterize what Chinese instruments have found on the lunar surface. The most striking example is the Chang'e 6 far side sample return. Those samples were collected from a location that no other nation has ever accessed, using a mission architecture that no other nation has successfully executed. The scientific findings from those samples will be determined by Chinese researchers on a Chinese timeline, with international access dependent on formal collaboration agreements that China controls. That is an enormous amount of interpretive power over findings that could reshape our understanding of the early solar system. To be clear, there is no evidence that China is falsifying data or suppressing results in some nefarious way. The evidence points in the opposite direction. Chinese space scientists appear to be doing rigorous, legitimate science and publishing genuine findings. But there is a difference between falsifying information and controlling the narrative around information. And the pattern across China's lunar program, the speed of anomaly resolution, the selective detail in official announcements, the gaps between mission completion and publication, the restricted raw data access, does not look like a program that is simply sharing everything it finds as fast as it can. It looks like a program that is being very careful about what it says, when it says it, and how. The real question. Jeremy Wade, the man who spent decades fishing in remote rivers and then built a television career around it, said something in his later years that has stayed with me. He said that incomplete truths are more dangerous than no truths at all, because they let us believe everything is manageable. China's lunar program is not a mystery in the sense of unexplained phenomena or hidden secrets. The mystery is subtler and in some ways more consequential than that. China is telling us the truth. The science is real, the discoveries are genuine, and the findings are being shared with the world. But they are telling us the scientific truth, while the fuller truth, the strategic truth, the truth about what these missions actually represent and what is being built toward, gets communicated in timelines and mission profiles and partnership agreements that most people never read. Every Chang'e mission has found something that does not fit the model. The layered subsurface structure, the unexplained far-side geology, the gel-like substance, and the angular rock that got explained and closed quickly, the 2-billion-year-old volcanic basalt that rewrote the timeline, the South Pole water ice deposits being characterized with survey-grade precision. Taken individually, each of these is a fascinating scientific result. Taken together across more than 15 years of consistent, well-funded, strategically targeted lunar exploration, they form a picture of a country that knew what it was looking for and has been finding it piece by piece, mission by mission, sample by sample. China says it is science, and it is science. But it is also something that has not happened since the 1960s, when two superpowers looked at a gray rock in the sky and understood, before anyone said it out loud, that whoever got there first was not going to the moon. They were going to the future. China is going to the future. They are going methodically, scientifically, with extraordinary technical competence and a timeline that is not a wish list, but a construction schedule. The real question is not what China found on the moon. The real question is what happens when they finish building what they are building up there, and why the rest of us are only just starting to ask.